Alright, so I'll start out with showing how I've derived the different linguistic patterns. So essentially I created this helper function, first of all, to print out first the category of the patterns. So this is how I often derive the user's intentions, and then I derive the actual text which was extracted using the linguistic pattern. Now let's initialize it here. What this does is it takes all the categories. So category entity lists is basically a dictionary with categories as the keys, and then another set of dictionaries essentially for each one, containing a list of the top 80 job titles or locations and that kind of stuff, which I've extracted. But what this is just words, a list, like words separated by spaces. Oh no, it's a list of all the words within the categories, which is how I ensure that these patterns do in fact contain words relevant for that. So first of all, you can see here I would like to work in the field of sales. So this pattern matches that, what you can see here. Essentially what I did was I looked into a potential query the user might make, and I've done some dependency parsing to derive that. I would like to work in the field of sales I found could end up being quite similar to the dependency list or dependencies which I would like to work in engineering, for example, which would be a pattern for deriving the job title. So I've specified that this also needs to be a noun, just to ensure that there's no confusion. In the second pattern, I tried to take into account compounding words. So this can appear one or more times, and this would allow the user to say something like, find me a position in consulting strategy, and note that position can be interchangeable with job, and this would still be accepted because because we're checking for nouns here. So moving on, you can see that the helper function manages to extract that this is in fact category, and these do match. Next, I've set this variable here to just be sales because I'm doing a similar thing here, but the thing is we need to take into account the category, because we've divided everything into categories corpuses, as different corpuses of descriptions. So here I'm doing a similar thing. So I'm getting all the words within this corpus which exist inside a title, and then I do the dependency parsing. And here I'm also trying to take into account compounds. So here it's also, as you can see, I would like to work as an assistant has a similar dependency structure as the previous one. So I try to include part of speech tags to be a bit more specific, and also I take into account the compound words. Here there are multiple compound words, just to demonstrate that this can be done. And print them out here, and as you can see, because these compound words are optional, it registers multiple patterns even though there's only one, so it's necessary to extract the longest possible title out of this, excluding position. So what I would do is I would loop over it, find all the nouns, and then just make sure that position isn't inside of it, or get rid of the very last noun. here we're determining the location. So we've got a job in New Zealand and find a job in New Zealand. What I found here is that this is becomes a dative object as opposed to here when it's the root. So I'll try to take this into account when creating this pattern. So you can see here, what I essentially do is I make these both optional. So you can either have a dative object here or a root here, and then the rest. And of course, I try to take into account compounds, so then you can have New Zealand as opposed to just, for example, Zealand or Australia. So for countries that are made up of 2 tokens, you can take that into account, and it recognizes it here for both of these potential user queries. Here I'm searching. This is a lot simpler. I'm not, in this pattern, I'm not really taking into account compounds. Here as well, so I thought maybe a user might want to look for a job in multiple companies. So got take into account that, but also this pattern will also be able to extract just, for example, I'm searching for an open position in Microsoft, for example, because these last 2 are optional, which is what this does. Now I think I can move on. This is another pattern. So this was my approach. I would just do the dependency parsing, and then I think I've already shown you this. I've tried more or less the similar tricks with every single one of them. So I'll go on to now demonstrate the chatbot. Okay. So here you can get some information for it. So it's you can see here the ID and everything you need to be able to access this. I think I'll leave the token in here for you guys to use, since I'm not sure how you can access it without it. But you've got all the information about it here. So this is a really long function. Definitely, I know there's a better way of doing it, but I'm basically taking all the patterns that I've shown you up there and just pasting it in here. I probably definitely should have just put them in a variable. Aware of that. I'm checking to see what this function does is it takes in categories, so nothing else can be used without category first being defined, and it returns a matcher, basically containing all the desirable patterns. But since category needs to be defined, it's only going to return one that can recognize the category. So this will be used by the chatbot. And we've got some helper functions. So this can extract the category. So it just loops over and gets the nouns out, pastes them together, and returns that. This returns the location. So we're looking for proper nouns. Yeah, this also takes into account the compounds by looping over it, extracting over it, and adding the spaces between them. And then, of course, removing the spaces, because this will result in spaces in here, and this isn't so good. Then I'm only noticing this now, so now I'm sorry. So because there's going to end up being a white space at the start, so we need to remove that space. So this calculates the cosine similarities, so the linear kernel. I read a bit online, understood that this is what this calculates, and then this line essentially sorts them and returns the top 10. But what I do here is I'm adding the query onto the description. So this returns category corpus is the keys of this one. Dictionary here is the actual job description, and I'm adding the query onto that and passing to the TF-IDF vectorizers, and then I take the TF-IDF vector and calculate the cosine similarity comparing the first description, essentially, so the first query to all the other ones. So these indices are going to be shifted to the right one, so you have to subtract that, and the first one will be the actual query. So that's a bit of a roundabout way of doing it, but that's the best way I could find. This sometimes there's I just want to extract the longest match from the query. I'll show in a second why, but this is used in more than one place, so that's why it has this generic name. This extracts the job title, so again we're keeping an eye out for position, because this is going to be registered as a noun, but we don't want that. And then this is just a function to get some message, so I'm trying to explain to the user what information the chatbot needs. So this is going to be called, and what these are essentially, did I pass it? This is a sort of state, like very, what's the word? Well, it's not the best way to do state management, but I think that for this purposes, this worked fine, and I'm checking here to see what information is missing, and if you get to here, then I'll show you what happens next. So you'll see in the demonstration. So let's go next. So I find this function, essentially it's a very basic scoring system I do. So I check to see if job title, locations, experience, or job type exists in the description of the job. Or in this case, I'm checking in the job title directly, but I'm just trying to get this match of the jobs of different user inputs, and then I add this to the score. And here I have this base score, and it's essentially just how highly ranked the job description was from the cosine similarity. And then I just sort them, and I wrote everything into a CSV, all the corpuses. So I load this into a pandas, and I just return this. Or I locate the index, because that was also stored in the dictionary that I have. And here's the actual chatbot. So the code here is a bit messy. This is just to make sure that they're referring to the global variables. So again, that's the state management I have for this. I think then this code, the best way to do it is to just demonstrate it. So let me just go ahead and run it. I have Telegram run open here already. So let's do it. So I'll say, okay, so I reset everything. So I can write it. First I need to specify the category. So I'll do, so this should find it. Yeah, so it can say that it can recognize that I want a job in the field of engineering. So this is going to be my category going forward. So next it's going to walk me through. So this is again this is again here, it's walking me through what information it needs. So I can say now find a job in Australia, and it should, okay, and it recognizes it. And the mode is just, part-time casually, so I would like to work full-time. And now it wants some of my work experience. I can say I have 10 experience. And I can also just say some gibberish, and it will just ask me to phrase it better. So then I would have to specify the job title. I'm not actually. this is not great, but since it's only 2 patterns, there's especially job title, there are lots of ways to phrase it, so I'm a bit lost. Let's say just simple. Okay, so here I'm doing the cosine similarity, so any description here, so something that I'll try to write like some keywords in there that might help it find the right job. So chemical engineering. So just something that might help it narrow it down, and then it will give me the job description. So here, communications engineer, Defense Melbourne. So yeah, so it's I said chemical engineering, so I didn't pick up on that, but this is the cosine similarity, so it's a particular way. Then I've provided here the link. Hope this demonstration was fine. So, but yeah, so yeah, enjoy.